Hello everyone, welcome to my talk called Password Correlation, Quantification, Evaluation, and Application. My name is Jonathan Henney, and we are going to start this overview with the topics of what are passwords, what is password cracking, some of the related work that I found interesting in the research paper, the data set that the researchers used, and how they took data from that. And then we're going to talk about what they call password correlation, which is only part of their paper, but for this overview, this part we're going to touch on the most. I recommend looking into what they called password social correlation that they dig into more in the paper, which I will have references to at the end. So, passwords. They are text-based authentication where a user puts in text and is able to prove who they are by something that they know. This is a very old way of doing things in computers, and this is very scalable because they are able to make their passwords as long as they can remember and as long as the computer can handle, which is very long. And it's a very simple method also because the admins only have to provide text boxes and then a little bit of a few algorithms to securely store these passwords. And all the user has to do is remember it and then type it in when they're trying to get into information. And one of the other big benefits is they are very high performant when they're done right, because passwords are very hard to break, even though every single password can be broken given enough time and compute. So some of the ways that passwords can be cracked are known as Markov modeling and structure-based, which these are two forms of algorithms that are used for password cracking. And some tools that are used are called John the Ripper and Hashcat. These are both good tools that are worth looking into. So one of the questions that the authors really wanted to present to their readers is what is the reason for the success of these password cracking techniques? How are they done? If passwords are so secure, then how are you able to crack them? And this comes down to the simple fact that humans are predictable. They do similar things in similar patterns, and this is all from different categories: demographic, behavioral, cultural, lingual, regional. All different depending on where you are in the world and what parts of the world that you are in the most. And another thing that the authors were trying to very much drive home with the latter half of their paper, which I do not go into much detail here, is they wanted to emphasize the effects that social profiles have on password cracking. When you are able to tie a social profile to a target, then it's because humans are predictable. You are able to learn things about them. And when you learn about them, you can predict passwords easier. Things that you might look into is what's their education, what career field are they in, what are some hobbies they have, and who are their family, and what relationships do these people have with family, friends, and special dates. So some of the other research that these guys talked about in their paper were the tools that were the ordered Markov emulator that just took descending probabilities and walked through, and I'm guessing a Markov random chain to add some entropy to the password generator to hopefully grab the password in a short amount of time. Then there was the probabilistic context-free grammar that was a tool that was developed by some other people that was referenced in the paper that builds grammar based on the data set space of the possible passwords and runs off of that. And then the authors talked about something called VCT, which they didn't give an acronym for, but it took the PCFG from above and added structure, syntax, and semantics on top of this, where this is building how are words and how are other parts of the password working together to form something that the user might remember, and how can you crack that. And then they talked about an interesting piece of research that they also referenced, which that researcher studied the effects of expired passwords, how that affects data sets, how many people go through and just add on an extra digit at the end of their password when their 60 to 90 day network-based password expiration comes up, just out of the simple fact that, again, humans are predictable. And then they dug into the John the Ripper tool, which they discussed had 4 different modes. These were the word list, the single mode, and the incremental and Markov modes. The word list took a dictionary and a hash table and ran that against a password hash, and then the single took a password hash and another parameter such as a username or an email, and would run that against various data sets or targets. And then the incremental used, as they called it, an intelligent brute force cracking method, which I plan on looking into more because this is an interesting tool. And then the Markov model, which I'm guessing followed a dictionary and structured that then just walked through it in a Markov random order. And so here in this figure, we see the data sets that these researchers used to pull their sampled passwords from. And 2 of these are from China and are Chinese-based databases, and then it also used 2 American databases, LinkedIn and RockU. And they sampled 3 million unique passwords from each data set, from each of the different databases as their samples to perform analysis on. So to touch a little bit on the ethics of this whole process, all of this information is currently in the public domain, even though at one point it was private information that was illegally breached and or leaked, legally or not. But it's public information now, so these researchers decided to use it not in any malicious way, but just to train their models to hopefully make passwords stronger for everybody, not just the people who did or didn't know about these data breaches. So as they go into the quantification and evaluation stage of their paper, they note that the CSDN and the Dinui datasets are related, and the LinkedIn and RockU datasets are related. And this kind of makes sense going back to the different factors that go into the similarity of passwords, be it in this case the linguistic, cultural, and behavioral patterns, because the first 2 data sets are Chinese based, and then the second 2 data sets are American based and English. So they talk about in the paper how the question of quantifying the correlation of 2 password data sets is an open problem, and that's one of the main problems that they're addressing in this paper. And this is some of the ways that they do it. And they start out with the structural based approach, where they take the PCFG tool and the VCT tool, and they use the letters, symbols, and digits that could be used in a password and form vectors of all possible passwords in that data set. And they construct, as you can see here, these F functions. These end up being the fraction of passwords having a specific structure, SI, and then over the whole set of passwords. So given 2 vectors of passwords, they calculate the Jacquard index of similarity, and then also the cosine similarity index. And then this gives them a data set that they're able to analyze and show. So then they also talk about the Markov-based way of doing things, which is very similar. It just uses the Markov n-gram methods, where they use tools like Omen and other software tools they mention about using this n-gram units of the passwords. And so very, very similar passwords or formula structures, pardon me, for this psi and these two psi terms, where they are very similar to here and here, but with simple index changes to denote them as the n-gram. And for both of these terms, here and on the previous slide, the Jacquard similarity indicates common n-grams, and up here it correlates to common structures of passwords. And then the cosine similarity is the distribution of the entire data sets together. And then they also talk about dictionary-based correlation quantification, and I left that out for brevity, but it's very simple once you understand the first two methods, and they talk about it more in the paper, and I recommend looking into that. So here's a graph of the here you can see the various, which data set is to which, and then over the structural, the gram-based, and the dictionary-based, what kind of correlation factors we're able to see through here. And as you can see, some of these are very high, mainly the two Chinese data sets and the two American data sets. And then in the middle is the cross correlations. And notably, the similar ones are all coming out higher than the cross-correlated ones. And then down here, this is the cosine similarity, and this is the Jacquard similarity. And then the next slide I have is an interesting set of graphs that they did, where they took the quote-unquote attacker's perspective, where they wanted to crack a specific database, and they took a model that we've talked about before. This is John the Ripper down here, and then they trained that model based on a different data set. And you can see here also that, for example, this Chinese data set, when it's trained against a Chinese data set for especially Omen and John the Ripper, over the Markov model, are very high, almost 25% chance of getting password correlations. And that trend you can see for these two Chinese ones are very high. And then as you go into the American ones, the American correlations are very high. And another interesting point is that the cracking the Chinese data set trained on an American data set, specifically the RockU data set, is also not a very low number. Certainly a usable number for what these potential attackers would be wanting to use. And so then the researchers go in to talk about some of the social profiles and how some tools can be built to make people make better passwords. And it's a very interesting paper. I highly recommend it. Good information in there. And so in conclusion, we went over passwords and password cracking techniques at a very high level, and then we went into some of the related work and interesting pieces of software and research that are being done in this field, and we talked about the data sets used and some of the ethics behind just password studying in general. And we talked about some of the password correlation, and we left out the password social correlation that they go over later, as well as a couple of the more nitty-gritty mathematical details. And so here is a reference to the paper for these guys, and thank you for your time. It's the end.